Hi everyone, welcome back to our Jupyter Notebook series. Today we will dive into how to import datasets and create stunning visualization right in Jupyter Notebook. If you missed our basic tutorial, be sure to check that out first. Let's get started. Oh, by the way, I have got something awesome to share from Red Decoder at the end of this video, so stick around till the end of this. For now, let's jump to the data visualization in Jupyter Notebook. First thing first, let's import the libraries we will need. So here we have imported Pandas library, and for data visualization, here we have imported Matplotlib. If you don't have these libraries installed, you can install them using pip. Now after importing these libraries into the notebook, here we are all set to start working with the data. In this line, we are loading the data. We have iris dataset here, and with this read CSV function, we are uploading the data to this dataset. This kind of CSV file, either you can upload from Jupyter Notebook interface by using this upload button, or you can simply keep your files in the same directory where you are working on. Now, before proceeding further, let's first understand the data. What we have this iris dataset. This is an iris data. Iris dataset is one of the most famous dataset in machine learning and statistics. So iris is a flower and it has various species such as iris setosa, iris versicolor and iris virginica. So these three are the species of this flower. Accordingly, it has four attributes: sepal length, sepal width, petal length and petal width. So in this dataset, we have these 5 columns: sepal length, width, petal length, width, species, and the another 6th column we have is ID. Coming back to the code, so after loading this data into dataset variable, here we have used head function which will give us first 5 rows from the dataset just to have some quick overview of the data. So here we can see as an output, it is providing us all 6 columns and first 5 rows. The next function we can see shape. Shape function provides the dimension of the data set. So it will provide us the number of rows and the number of columns. As we can see here, the number of columns are 6. So here it is providing the second value as 6 and the first value is 150. That means it has 150 records. If we talk about shape 0, that means we are trying to access the first value which is 150. Now here we have a function columns, and in this line we are trying to get the column names and we are trying to convert it into the list. So what was the column here? We have the column as sepal length, width, petal width and species as well as the ID. Here this function will provide the list of all column names. The next function is dtypes, which will provide us the type of the data stored in each column. So here in ID column, we can see the value type is integer. In these 4 columns, the value type is float, and here species type is object. Going forward, we have another function string.replace. So here in this line, we are first reading the value of species column, and by using this string function, we are going to replace the occurrence of iris hyphen with this blank. That means from each value of species column, we are going to remove this particular substring. So here if we will go up and we will see what was the value we had in species column. It was iris setosa, iris versicolor, but after removing this, it will become setosa, virginica and etc. So this function is simply removing the occurrence of iris hyphen substring. Next function we have value counts. So under this column species, it is just giving the count of all different values. These 3 unique values we have in this column, iris setosa, versicolor and virginica, each value is coming 50 times. So this function is providing the frequency of each unique value. Next, we have a describe function. The describe function plays an important role in Pandas library. So it is providing the descriptive statistics of the given dataset. Here we can see corresponding to each column, it is providing the count, mean, standard deviation, min, max and other things. So by using this describe function, you can get quick descriptive statistics of the dataset. Here on this Pandas dataset, you can use the lambda function as well. So here we have applied lambda function of this species column of the dataset, and we are trying to get the values after 5th index. So the original value was iris-setosa, and here we are trying to get the value from fifth index, that is setosa only. Then we can get the mean of a specific species as well. So here by using this function, we are trying to get the mean of each and every unique value of species column. So for each unique value of species, Iris setosa, versicolor and virginica, it is providing the mean for each column. We had 4 attributes: sepal length, sepal width, petal length and petal width. For each column, it is providing the mean of species. Then here we can group the species and we can evaluate the mean, min and max value as well. So here we can see corresponding to each column, it is providing these 3 values: mean, min and max. So these are the various functions we can use from Pandas library to get some statistics or analysis. Coming to the second library, that is Matplotlib, which we use for the data visualization. And here on this data set, we are trying to plot a scatter graph. So here we are going to use pyplot from Matplotlib, and with this plt.axis, this is the function which we can use to create and customize the axis in a plot. So it allows the fine control over the placement, size and appearance of the axis within a figure. After creating this axis object, here we have a scatter function which we can use to plot a scatter graph below. Here in the parameters, we need to pass the data on which we want to plot the scatter graph. So here I am taking 2 columns, sepal width and sepal length. Between these 2 columns, I want to plot this scatter graph. Some labels we can use by using this set function. Here we are setting the title as sepal length versus width. We have put the x label as sepal width and y label as sepal length. Because in x-axis we have defined sepal width and in y-axis we have defined sepal length. So as an output of these lines, we can see this scatter graph which is being plotted by considering different values given in the dataset. Similarly, as Matplotlib provides various functions to plot various kind of graph, we can plot some histogram as well. So to plot the histogram, again we have first created some customized axis, and to plot the histogram we have used a hist function and we have passed the required data in the parameter, and here is our histogram. So it is bit similar to the Python coding. Generally, as we write the codes in the similar way, we can write the code in Jupyter Notebook and we can get it executed. So here we just explored how Pandas and Matplotlib can superchange your data analysis and visualization in Jupyter Notebook. Whether you are cleaning messy dataset with Pandas or creating stunning visuals, these tools are must-have. The benefit of using Matplotlib and data visualization with Jupyter Notebook is we can see the code as well as we can see the output in the same place. You can convert this in some PDF and you can share with everyone. Going ahead, we are planning to come with 60-second programming shorts that will include quick, unique and actionable insights on Golang, Python, machine learning and data science and much more. That's easy to learn and fun to watch. Thanks for watching. If you found this tutorial helpful, don't forget to like, share, subscribe and hit the bell icon for more tutorial. Happy coding!